Hi, welcome to an Arduino tutorial from Robojax. In this video I'm going to show you how you can control a DC motor using infrared remote and infrared receiver with Arduino using L293D. To rotate it right like this, when I press it, it rotates now right, stop it, and then rotate it left. I will show you how to use the silver remote, black remote, the receiver with PCB and the receiver without PCB. You can get the code for this project by clicking at the link in the description below, which will take you to robojax.com/learn/Arduino. Let's get started with this. In this video I'm going to show you how you can control a DC motor, a tiny DC motor using L293D chip with infrared and Arduino. And I'm going to demonstrate these two types of remotes. I have separate video explaining how to receive signal from these two remote control with the PCB version or without the PCB version of this 1838 receiver and Arduino. So you have to watch that video, make sure that when you press these keys you receive the signal on the screen. Make sure that you are able to use whichever remote you have, either you have a black or the silver one, or if you're having this PCB version or without the PCB version, make sure that you run the code, download the library, and it should be able to display that response from the key that you press on the serial monitor. Then I have another video explaining this L293D chip. Make sure that you are able to control a motor using this with Arduino. After that, then come and use this combined code that I've provided, and for sure it will work and you're able to control the motors using this remote control. Now let me explain the wiring for this chip. The first thing is that pin 16 goes to 5 volts in here, which I'm going to connect this portion to Arduino, and here it shows pin 16 to VCC1, that is the 5 volts. Pin 4 and 5 are connected together, both of them to ground, and here pin 4 is connected to pin 5 and both of them are connected to ground. So this is my common ground. Here we have, for the motor, I have 4 diodes here. Anode of 2 diodes are connected, so one diode is connected from ground, and cathode of this is connected to anode, and this is connected to VCC2 voltage for the motor. So the one pair, and then I have another pair, so 2 pairs from ground, anode, cathode of this to anode of this one, and this is connected to the positive. Now let's check here. So I have one diode here, anode, and that's cathode, and this is anode, that is cathode here. The anode of both of these are connected to ground. And now look, this one which comes and then anode and cathode goes here, this anode, and then cathode of this one is coming here to the anode of this. Both of these are together. From here we will connect it to the main power supply, the 12 volts, 9 volts, whatever is the power supply for the motor. So this goes to the power supply of the motor, and this one goes to 5 volts of Arduino. I will remove this for now. Pin 3 and pin 6 are connected between anode and cathode of one diode, and then 3 is connected between the other one. Doesn't matter which one is which, so I'm connecting pin 3 to the middle of these one diode and the other diode that are coming together. And here pin 3, this is pin 3, 1, 2, 3, and I'm connecting it and here between these two diodes. And here I've connected pin 6 to the middle of these two diodes. So this diode is coming here, the cathode of this diode and anode of this diode. That's connected to pin 6. Now here is a motor. For the motor I have 2 wires. The wire for the motor will go exactly between anode and cathode of one group, which is here, and the anode and cathode of the other one, which is this blue. This is exactly the same as if we say pin 3 is connected to the motor, and we can say pin 6 is connected to the motor. So pin 3, blue, is connected to the one wire of the motor, and then 6 is connected to the other one. Because the direction of rotation of this motor can be switched, doesn't matter which one is which, but if you have some preference, just switch it, remove this, and connect it the other way. From pin 8, that's coming to the pin 1, that's the enable, that enables this portion and this portion, both sides. So pin 8 is this gray wire here. I'm gonna connect it to pin 1. And pin 7 of this chip, I have arranged it such that pin 2 will be connected to pin 2 of Arduino, pin 7 will be connected to pin 7 Arduino. This is connected to pin 7, the white, and I'm going to connect it here to pin 7. And that pin 8, pin 7 is here. This is connected to the VCC to 5 volts, this portion, and this line is connected to the ground of Arduino. I've connected this wire to 9 volts of external power, and this is to the ground. Ground is connected to the ground, which is connected via this yellow to the ground of Arduino. If you're using this PCB, the signal goes here, this goes to pin 11, the middle goes to 5 volts, and then here it says minus, this goes to the ground. If we are using this bare module, here are the pins. VCC from this side, VCC, ground is the middle one, and then this goes to pin 11, which is the signal. Connected the signal to pin 11. Ground if have been connected here. VCC is connected here for both of this PCB module, and without the PCB, the receiver. Let me now explain the code. I've explained it in a separate video that I mentioned, so you have to watch that. Here I'm not gonna explain it. The only thing that is concerned in this video is a black remote, just type black inside a single quote, and if you're using white remote, just type capital Y. Also, if you're using this module, or I call this PCB, so PCB equal 0 if you're using this one, and if you're using this PCB, set this equal 1. This false or true display is to display the code here. This is to display the code here. If you want to know the code, set this equal TRUE, true. We have 3 commands here: right, left, stop. If you're for the right, we have to know which command or which key we are using. And for example, this is for the black remote, capital B, so right arrow inside the double quote, left arrow inside the double quote, or OK. This must match the code that is the label of the remote here. These are the label for the remote, and it must match, otherwise it will not work. After this, you do not change anything, you just go and read it. So this is for the black remote with PCB. These are the codes. These are the hash code. This is the white remote code for decoding purpose. This is the white remote key. These are the labels for this remote. I've put them in 3 because each row has 3 keys. And this is for the black remote, the code for the black remote with PCB. When you are using a PCB version, the code will change. And these are the black remote labels, and these are the labels that we need to know. This is the up, left, OK, right, and then down. We have 4 keys here, and I put them inside the double quote, and the key that you are selecting to control it must match. So this is the way it is. So this key that you're using must match this, otherwise it will not work. P1A is for the DC motor. We set pin 2 and pin 7. These are the 2 pins. So this is for pin 2 and pin 7. These are the input that is coming from Arduino, and pin 8 is enable 1, 2. That is for will be connected to pin 8. So if you are using the pins for other purpose, change this accordingly between 2 to 13. And pin 11 is here for the receiver as well. Make sure to set this 11. If you're using different pins, set that accordingly. So this portion is for the motor, and this is for the receiver. Inside the loop, we check if decode result is true. So this means if true, then we do all of this. So see what we do. We say if the display code serial. So first, if we set the display code to display the code for us, then we print it as a hex value, and also we say Robojax validate code, and we pass the result dot value, and then infrared resume, and we wait 500 milliseconds, and the loop continues. This portion is done. I explained the validate code in my other video. The only difference is this was a relay action or some kind of action. Here I put as motor action. This is the line which passes a value for the remote. This is the value that is printed on the screen. Also we are passing it. This is when we have white remote with PCB, white remote. This is when we have white remote without PCB, white remote and PCB. This is a black remote and PCB, and else this means black remote and not PCB. In all of those we just pass motor action, and we pass this value. So the motor action will take the value for the remote. Now let's go for the, and this is the motor action, and we check it here. If we say that if the value that we pass is equal the right, this right and left and stop are the values that have been defined here, right, left and stop. So we say if the value is equal right, we say L293D, R mean right and 1 mean enable. And for the left, we just call the same function left and then 1 mean enable. And if the value is equal to stop, this doesn't matter right or left, but here is the important part, 0 mean stop. And here L293D that I've written, it receives two parameters, a character and then 0 or 1. And the character arrives here, we call it dir, direction, and enable the value, the other value that's 0 or 1, we call it enable, en. And here we check if dir or the direction values, this is double equal sign, which means comparison, left. Then here is what we do. Then we say if enable is there, we just say motor stopped. And if the enable is not there, we say motor is rotating, and then we enable the pin. So this is pin 2. Enable mean if it's 1 it will be enabled, if it's 0 it will not be enabled, and then we send pin 1A and pin 2A. One is high, the other one is low. When we have this equal right, then here the difference is this will be high and low, and here will be low and high. So this will change the direction of the motor. And automatically if enable is equal 0, doesn't matter left or right, the enable will pass here in both cases, and the motor will stop. Let me now demonstrate it. I'm using the black remote to control the DC motor, and on the sketch you have to set the type of remote, B for black, as it has been explained in my original video, and PCB is equal 1 because this is now PCB, and false display is set to false. I'm using this right arrow key for the, so for this controlling remote we have 3 commands, for the right, for the left, and for stop. So we have to have 3 different commands in order to control motor to rotate right, left, and stop. So one it will be counterclockwise or clockwise. So I just use right and left. And this remote has labels. As right, I'm using this right arrow to move the motor to the right or clockwise, and then this goes counterclockwise for the left. And then there is OK button, which I have filled this up inside a double quotation. So these are very important. The black and white is also single quotation, and then PCB is equal 1 because I'm using PCB. I'm going to also test this one without PCB. And press it to the right, so counterclockwise, rotating, stop it, and then clockwise. I've set these two different LEDs so you can see the change in colors to tell you which direction it's rotating. You can directly go to the other direction or just stop and then go to the next direction. For this silver remote, we can use these labels that I've defined it inside the code in the original video. So either we can use this, or any of this that you want. For example, we can use plus, minus, and equal. So this one, whichever you prefer. Let's go for the channel. Channel plus to the right direction, to one direction, channel minus to the other direction, and CH. So here they have been defined exactly here, CH, capital CH, capital CH, capital CH with a plus, minus, and the middle one, which is CH, it doesn't have anything. So we have to define it first. So this is white remote or silver, so I put W because we're using PCB, so that's PCB, and here let's put CH plus. So we are defining the key that is there. So, and PCB is equal 1. Let's upload it. So pressing it to the right, and then pressing the middle one to stop, pressing the left, directly go to the right, stop, now I have removed the PCB module, just the bare 1838 module here with the silver. The only difference at this time is that I set PCB equals 0. Let's just test it. Pressing this channel plus, CH plus, stop, and then channel minus, so clockwise. You can go directly clockwise or stop. For the black remote, I've set type capital B and PCB equals 0 because this is not PCB and PCB is here. Now with the black remote, this key, that arrow to the right, rotating, stopping, go to the left, stopping. Thank you for watching. This was how to use these two remote control with Arduino to control a DC motor, change the direction, and stop it. If you learned something from this video and if you like it, please thumb up and also subscribe so you can get updates of my upcoming videos. Link for our Facebook page is also at the bottom of the description.